Okay, if you were absent for the weighing amines of counting lab, this video will help you walk through the process of doing it. So the first thing is uh, kind of how this lab went. If you were here, here's what you would have done. So what you would have done is you would have went to a station where there was some water, and you would put so much water on the balance in a cup, and you would mass it. And so these masses are things that you could have possibly gotten if you were here. And so we're giving you the masses, but if you were in class, you would have actually massed these things out. And so what your job is to uh, fill out what's missing here, and you're going to calculate how many atoms are in 16.5 grams of water. And then you're going to do the same for salt, sugar, glass, chalk, lead, and aluminum. And so I'm going to walk you through a couple calculations. So the first thing that you're going to need to do is think about the formula for water. And so water is H2O. So what you would do is just write H2O. And I put the calculations here for you. And there's actually a worksheet that goes with this that you would need to pick up. And so you'll need to get the worksheet for this. It's just a blank data table. You can fill in the masses here, and then you can write the formulas. Now I wrote some of the formulas for you because I didn't know if you would know them, but the lead and aluminum and water, I guess you should be able to figure out. But anyway, okay, now what we're going to do is we're going to do the molar mass for water. So to do a molar mass, you have to figure out how many atoms are in the formula. So there's 2 hydrogens, and if you look at the periodic table, each hydrogen is about 1 gram. So 2 times 1 is 2 grams. There's 1 oxygen in H2O, so 1 oxygen, and that's about 16 grams. So you write that there. And so 16 plus 2 is 18 grams. Okay, so that's the molar mass. And so all the molar masses are going to be in grams. How many grams are in 1 mole? So we'll just write 18 there. All right, now what you're going to have to do is you're going to have to do a couple calculations down here to figure out this stuff right here. So we want to go all the way to atoms. But here's how you're going to do it. Step number 1, write down what the problem gives you. So the problem, what we did is we weighed out or massed out 16.5 grams of water. All right, so the first step is we're going to change it to moles. And so 1 mole water, then we're going to use the molar mass, which is 18 grams of water. Now this particular activity wants us to get the moles and particles and atoms. So we're not going to do a whole bunch of individual picket fences, but we're going to stop and we're going to do a calculation, do some calculations as we go. So right now the grams of water would cancel out, the number wouldn't, but the units would, and we'd be in moles. So if you took your calculator right now and you took 16.5 divided by 18, you would get 0.92, something like that. It'd be like 0.917 actually. And so I'm going to write that right here. So I'm just doing a calculation, but I'm not stopping my picket fence. Also notice, since this had 3 significant digits, I'm showing 3 digits in my answer. All right, now I'm going to keep going to particles. All right, so then I'm going to go for every 1 mole. Notice how I'm following the principle of diagonality. Moles, water. That equals 6.02 e to the 23rd. And now we got to put a label on water. And water is a nonmetal to a nonmetal. So the label would be molecules, water. All right, now we could stop our problem right there and we can end up calculating particles. So right now on your calculator should probably say something like this if you didn't clear it. So like mine says 0.91666, and it goes on for a long ways. So right now I'm just going to take that and I'm going to multiply that times 6.02 to the 23rd power, and that's going to tell me how many molecules of water. And so what I'm going to write that right there, I have it. So right now my calculator says 5.52. I know this is kind of hard to cram it all in here. E to the 23rd power. That's how many molecules of water. But we don't want to stop there. We want to go to atoms. So we're going to do one more step. And if you count up the atoms in water, here's water, H2O. In one molecule of water, we kind of did it up here already. There's 2 hydrogens and 1 oxygen. So in one molecule of water, there are 3 atoms. So then you just got to take the number on your calculator, because you have the particles, and just multiply that times 3. And so the answer ends up being, if you go out to 3 significant digits, it's going to be 1.66, there's supposed to be a point there, 1.66 e to the 24th atoms. So that's what, I'll just write it right here, 1.66 e to the 24th atoms. That's how many atoms are in water. All right, let's just go and let's do one more problem. So let's do the aluminum one. Aluminum is 16.2 grams. So there's a page that shows your calculations. So for aluminum, it ends up being 16.2 grams. Okay, the first thing you're going to do is change to moles. So 1 mole aluminum, if you look up aluminum on the periodic table, it's like 26.98. So I'm just going to round that off to 27 grams. All right, and I'm going to do the math here. So I'm going to take 16.2, divide by 27. And right now, if I stop the problem right now, see the grams, I should have the limit there, but the grams cancel. And so now I'm in moles, so I'm going to go back to the data table, and I'm going to put in for aluminum that, let's see here, that the moles, so the moles of aluminum would be, according to my calculator, it's going to be 0.600. The molar mass was 27. The formula was Al. I didn't put that in there. So I have about 0.6 moles. Notice how I put 2 more zeros because I'm trying to match the 3 significant digits there. Okay, so then I'm going to go and I'm going to keep going to particles and then atoms. All right, so now I'm going to go to particles. And so I'm going to go 1 mole aluminum, and aluminum is an atom. It doesn't form a molecule or a formula unit when it's just by itself. So you can go 6.02 e to the 23rd, and you're going to label that atoms. So I'm just going to take my calculator, which has 0.6 on it, and times that by 6.02 to the 23rd power. And my answer that I get for atoms is 3.61 e to the 23rd atoms. And then I would go back to my data table, or go up to your data table. Now you can put in that aluminum is atoms, so we could just, the particle that it makes is an atom, so this would be 3.61 e to the 23rd, and that is atoms. Notice that it's 1 step shorter because aluminum isn't a molecule or a formula unit, so it's actually 1 step less than the water type of problem. Okay, that's it. What you need to do is take the rest of this data right here and finish this lab. And that's it.